Page 125, we're going to take a look at problems 3 through 6. We're asked to use the following data obtained in a study of age and systolic blood pressure on 6 randomly selected people. So we've got the 6 people, so A through F here, that's the 6 people we're talking about. And here's their ages and their blood pressure. So the first thing we're asked to do is construct a scatter plot of the data. So over here I'm going to put a set of axes. And if I were doing this on a test or project, I'd pull out my ruler, but for now, we can make a rough sketch. Now, your age determines your blood pressure. So age should be our variable on the x-axis, and blood pressure should be here on the y-axis. Okay, so for age, we need numbers up to 70. You could start here and count off maybe by tens, or I can choose to. Well, the smallest number we need is 43, so I'm going to skip a little bit of space and start here at 40. And we'll jump up from there. So 40, 50, 60, and 70. And if you make this and have a completely different scale than I do, that's perfectly okay. Okay, blood pressure then goes from 120 to 152. So again, I'm going to skip a little bit here. We'll start at 120. I'll get 130, 140, 150, and we'll go up to 160. Okay, so let's get each of these points. So the first person is 43 years old and has a blood pressure of 128. That gives us a point right about here. Next person is 48 and has a blood pressure of 120. Next is 56, blood pressure 135. 61-year-old has a blood pressure of 143. 67-year-old has a blood pressure of 141. And the 70-year-old has a blood pressure of 152. All right, we should probably have a title on our scatter plot as well. So let's just put up your age and blood pressure. Okay, so that takes care of this first one. Construct a scatter plot. Second question, actually it's question number 4. Is there a relationship between age and systolic blood pressure? Yeah, it looks like the older you get, the higher your blood pressure. Now, it's not a perfect relationship for everyone, but in general, as the x value increases, the y value increases as well. So we can say that there is a positive relationship. And it also appears, now it's not a perfect straight line, but it looks like this data is going up in a linear direction, so it's a positive linear relationship. Okay, let's look at number 5. Estimate the correlation coefficient for the relationship above. Now, if these points made a perfect straight line, our correlation coefficient, which will signify with the variable r, would be equal to 1. In this case, I don't know, it's not a perfect straight line, but it's not too far off. So I'd say r is about, I don't know, about 0.9 or so. These points are pretty close to determining a straight line. Okay, last part. Use a calculator to find the equation of the least squares regression line. All right, so I'm going to put this aside, get my calculator out. There it is. And I saved myself a little time. If we press our stat key and then enter, we can enter our data into 2 lists. I did that already. So once that's done, if we press our stat key, we go over to calc. And what we want is the 4th choice, the linear regression equation. Now if we just press enter, it'll work out fine because list 1 and list 2 are the default lists. Or we can type list 1 comma list 2. If we had our data in different lists, we'd have to do that. Either way, we press enter, and it gives us our values of A and B. I'm going to pull these out here. But then I'm also going to write this down. So our equation is y equals, let me put these numbers in here, about 0.96x plus 81.05, where x stands for the age and y stands for the blood pressure.